Hello and welcome to the channel Beyond the Curve, and I'll be answering question number 7 of the 2024 May June FP1 paper. So the part A says, show that for all positive integers n, the summation of 12r squared plus 2r minus 3 from r equals 1 to n is an cubed plus bn squared, where a and b are integers to be determined. Right. So let me first write down the summation expression given. 12r squared plus 2r minus 3 from r equals 1 to n. I'll put a bracket over here. Okay, so the first thing we need to do is split the terms, as in write summation of 12r squared plus the summation of 2r minus the summation of 3. So we can write that as summation of 12r squared from r equals 1 to n plus, because there's a plus in front of 2r, summation of 2r from r equals 1 to n minus, because there's a minus in front of the 3, summation of 3 from r equals 1 to n. Now the first term is 12r squared, and we know the formula for the sum of the squares of the first n natural numbers, which is the summation of r squared, from the formula booklet, which is 1/6 times n plus 1 times 2n plus 1. So for this I can say 12 times write it here. Times 1/6 times n into n plus 1 times 2n plus 1, and then I'll put a bracket, or maybe I can take off the multiplication sign. Plus 2 times the summation of the first n natural numbers, which is the summation of r, but that's not given in the formula booklet, but we have to know it, which is half n times n plus 1. So 2 times summation of r, which is half times n plus 1, minus, now we have minus 3 only, a constant number. We don't have any r terms such as r or r squared or r cubed. But we do know that the summation of a series of constant terms is equals to n. r equals 1 to n will be n. So in this case the summation is from r equals 1 to n. But we have a minus 3, so we have to multiply minus 3 by n. And now we can simplify. 12 divided by 6 will be 2. Then we have 2n times n plus 1 times 2n plus 1 plus, the 2's cancel off in the second term. 2 divided by 2, 1, so n times n plus 1 minus 3n. I'll keep this 2n as it is and expand the brackets of the n plus 1 and 2n plus 1. So n times 2n is 2n squared plus n times 1 is n plus 2n times 1 is 2n and plus 1 plus n squared plus n minus 3n. expand it further. 2n times 2n squared will be 4n cubed, plus n plus 2n will be 3n. That times 2n will be 6n squared, plus 2n times 1 will be 2n, plus n squared. N minus 3n will be minus 2n. I'll simplify this further. 4n cubed, 6n squared, and then we have a plus n squared, so that gives plus 7n squared. And we can see that this 2n and this 2n cancel off. So that's our answer to part A. An cubed plus bn squared. Yes, they do match. 4n cubed plus 7n squared. Oops, wrong color. So we can say shown. Could also write where A is 4, B is 7. Yes, 4n cubed plus 7n squared. Moving on to part B. Hence determine the value of n for which the summation of r cubed from r equals 1 to 2n minus the summation which we found earlier in part A is equals to 270. Right. So we do know the summation, the formula of the summation of the r cubed from r equals 1 to n from the formula booklet as 1 over 4 times n squared times n plus 1 whole thing squared. So let me write that down in another color. R equals 1 to n of r cubed will be 1 over 4 n squared times n plus 1 whole thing squared. But we're being asked for, or we're going to have to use from r equals 1 to 2n. So all we need to do is substitute 2n wherever we see an n in the formula. So I'll get back to black. So I'll say summation of r equals 1 to 2n of r cubed will be 1 over 4 times 2n whole thing squared. So I'm replacing 2n for n, and 2n plus 1 whole thing squared. I'll simplify this. 1 over 4 times 2n whole thing squared will be 4n squared times 2n plus 1 whole thing squared. So that will be 4n squared plus 1 times 2n is 2n times 2 will be 4n plus 1, because 1 squared is 1, and I can cancel these 4's, and I'll expand the brackets now. So that's going to be n squared times 4n squared, which will be 4n to the power 4 plus 4n cubed plus n squared. So that's the expansion of, or the summation of r cubed from r equals 1 to 2n. And then we move on to what we found in part A. Summation of 12r squared plus 2r minus 3 from r equals 1 to n, which we found it to be 4n cubed plus 7n squared. So we can directly substitute. So summation of r cubed from r equals 1 to 2n minus the summation of, what was that again? 12r squared plus 2r minus 3 from r equals 1 to n is equals to 270. So this we found it to be 4n to the power 4 plus 4n cubed plus n squared minus, let's put it within brackets, from part A we found 4n cubed plus 7n squared, which is equals to 270. Now let's remove the brackets, so it's going to be 4n to the power 4 plus 4n cubed plus n squared minus 4n cubed minus 7n squared, and we can bring the 270 to the other side, so it will be minus 270 equals 0. When we simplify, we get 4n to the power 4, and we can see that 4n cubed, these two 4n cubes are going to be cancelled off, and then we have a plus n squared and a minus 7n squared, which gives us a minus 6n squared. So I'll write that down, and we have minus 270. Now this looks almost closer to a quadratic expression, except a quadratic expression would be ax squared or an squared plus bn plus c, but instead here we're having to the power of 4 and to the power of 2. We can work it out the same way. So if I use the quadratic formula, it can be n squared equals, usually we would write it as n equals and then the quadratic formula to find the roots, but in this case we're going to have to equate it to n squared. So n squared equals minus b plus or minus b squared minus 4ac square root of 2a. So minus b, we have the minus, and the b is going to be minus 6, so the minuses cancel off and we have a plus 6. Plus or minus, minus 6 squared will be 36 minus 4 times a is 4, c is minus 270. Square root, let me draw a beautiful line. Okay, 2 times a, which is 4. 6 plus or minus 36 minus 4 times minus 270, that is 4,356, and if I find the square root of it, we get 66. 4 times 2 is 8. So now n squared can be 6 plus 66 over 8, or n squared can be 6 minus 66 over 8. So 6 plus 66 divided by 8 will be 9. And 6 minus 66 divided by 8 will be minus 15 over 2. Now we can bring this to the form of a factor. So we can bring 9 to the other side. So this becomes n squared minus 9 equals 0. This we can say 2n squared is equals to minus 15, and minus 15 goes to the other side to become plus 15. So 2n squared plus 15 is equals to 0. So this quadratic, quartic expression can be written as n squared minus 9 times 2n squared plus 15 is equals to 0. But then again, we've already found what n squared is. So n squared is 9. So n will be the square root of 9, which can be plus or minus. So n can be plus or minus 3, or n squared is minus 15 over 2. But we can't find the square root of a negative number, therefore we say no solution over here. But the question asks us to determine the value of n, just one value. So they don't want a negative answer, because from part A already we've proven or shown that the formula for that summation is for all positive integers n. So our answer can't be a negative 3. So finally, since I'll write that again. Since n is greater than 0, n is equals to 3. And that's our final answer to part B. And that's the end of question number 7. If you liked this video, please like and subscribe the channel, and I'll see you soon.